We are going to look at how you solve absolute value inequalities. And the first thing, just a reminder that absolute value is the distance from zero. Well, now when we have an absolute value inequality, we still have an absolute value, so we're still working with a distance from zero. The only difference now, instead of being an equal sign, we have an inequality sign. So now let's think about what this would look like on the number line. If this had said the absolute value of x is equal to 5, I would go to the points 5 and -5 because those are both 5 units away from 0, and I would plot my points there. But what this is telling me is I want things that are less than 5 units away. So if I want to be closer than 5 units away, I want to be in all of these points right here and all of these points over here. So what ends up happening is we end up having a number line that gets shaded. So I do not have the equal to component, which means I have to have an open circle again, and I want the things that are closer. I want absolute values that are less than 5. Well, now with my negative portion of it, I'm actually going to the greater than side, because when I'm talking about a distance, these numbers in here are less than 5 units away, even though they're negative numbers. So I'm going to have my open circle there on -5, and my graph would look like this. Well, now if we break this down into two parts, because with absolute values we always have two answers, I have to do two things. If I just look at this first half here, that would be kind of like the inequality x is less than 5. When I come and do the negative side here, though, since I shaded to the right, that's like the inequality x is greater than -5. If you compare that to what we started with, the first one I wrote here, x is less than 5, that is our starting inequality without the absolute value signs. So that one, we always start as normal. Now the second one, two things happen. Number one, my sign switched. In my original, my inequality was pointing at the x. Over here, it's opening towards the x. And then I also changed the sign of my number out here. So it went from +5 to -5. That's my second inequality that I will be setting up. So the first inequality you set up just regular. The second one you flip the sign and change the sign. Now if you think back to compound inequalities that we've done, when we shade towards each other we often call that an AND inequality, because you have to be less than 5 and greater than -5 at the exact same time. So we would write this inequality just as one string. We would start with the -5 because that's our smallest, put that on the left. Our inequality points at the -5, then we put our x. And then we come over here and we don't have to double up our x again, but our inequality points at the x, and then we follow it with our 5. So we would write our answer for this one using that compound inequality, and it is an AND. On the second one, we start out a little differently. I have the absolute value of x is greater than 5. Well, that means in terms of distances, I want to be farther than 5 units away. So farther than 5 units away would be like 6, 7, 8, or it would be like the negatives 6, 7s, and 8s. So those would be farther away. Well, I have to start with my two inequalities, and the first one again is going to be exactly like this, just without the absolute value signs. So I'm going to have x is greater than 5, and now if I write the inequality for this half down here, my negative sign, I'm going to use that -5, and I want my x to be smaller than, because I shaded to the left, so I want x to be smaller than -5. Notice again to get the second inequality. In my original, the inequality opened towards the x. I had to flip it. Now it's pointing at the x. I had a +5. I have to change that now to the opposite, a -5. So now I have my inequalities. On my graph, I need to go back here and I need to put open circles on my 5 and on my -5, and then make sure I get my shading. Now this one, you cannot be below -5 while at the same time being above +5. So this one is an OR compound inequality. So we have to write our answer with an OR here. So we want x to be less than -5 or x to be greater than 5, because they can't be an AND. They can't do the same thing or they can't do both things at the same time. Now if we compare these, how can you tell if you're going to have an and or an or before you even finish your problem? Well, to get an and, the inequality points at the absolute value signs. So an and points at the absolute value signs. If you look over here, it's not pointing at the absolute value, so it has to be the or. So if you can remember, an and points at the absolute value signs. That'll help you decide if you have an and or an or. Okay, here's our first set of practice ones. It says solve each. So this first one, 6x plus 1 is less than 25. I have to set up two separate inequalities, and the first one is going to be just like the original, only I take off the absolute value signs. The second one is still going to be 6x plus 1, but now I have to flip the sign and change it to a negative 25. Now, before I continue, I'm going to decide, is this going to be an and or an or? Well, my inequality is pointing at the absolute value sign, so I know that this is going to be an and inequality. Then I need to go through and I need to solve each of these inequalities. Once I get each side solved, I need to put them together in an and format. So I need to start with my smallest one. So I have negative 13 thirds. And it's pointing at the 13 thirds, so I need to point at the 13 thirds. Then I have my x. Now I jump to the rest of this and I'm going to tack on the 4. So my answer would be x is less than 4 and greater than negative 13 thirds. Our second one here, absolute value of 12 minus 3x is greater than or equal to 0. So I'm going to start this one out with writing the original without the absolute value signs, and then writing my second one. Remember, when you write your second one, you leave the inside part alone, but you flip the sign and you change it to the opposite. Well, we have an issue here. 0 doesn't have an opposite. There is no negative 0. So this one is essentially not used. Then you just do your regular algebra to solve this. Now remember, when you divide by a negative, I have to divide by negative 3 right here. Don't forget, when you divide or multiply by a negative, you have to flip the sign. So for this one, we get x has to be less than or equal to 4. Okay, our third one down here. First thing I have to do is I have got to get rid of this 2 on the outside of there before I start working with my absolute value. So I'm going to rewrite it as 7 is less than or equal the absolute value of 3x plus 1. Now I can go ahead and set up my two separate inequalities. So I'll write my first one is just going to be 7 is less than or equal to 3x plus 1. The second one would be negative 7 is greater than or equal to 3x plus 1. I leave that 3x plus 1 alone. I flip the sign and I change that to its opposite. Now I've got two equations I can go ahead and solve. Once I get down to my each individual ones, I have to go back and I have to decide, is this going to be an and or an or? And since my inequality is not pointing at the absolute value signs, it's going to be an or. So to finish off my answer, I need to put an or in between them. And there I would have my answer. Okay, one use for absolute values is tolerance. And if you think about a business that packages cereal, they have an advertised amount on the box as far as the amount of cereal that's in there. Well, the company isn't going to be perfect, so the boxes of cereals are going to be different, but they have to operate within a certain tolerance. They're not going to be happy if their cereal is missing 5 ounces, or if they have 5 ounces too much in their box. So they have to operate within this tolerance, which means, you know, what are we okay with as far as being off? Are we okay with being an ounce off or a half an ounce off? That's what a tolerance is. We have a formula that we'll use whenever we're dealing with tolerance, and it's the absolute value of the actual box or the actual item minus the ideal, and the ideal is, you know, what do we really want it to be? And we want the absolute value of that to be less than or equal than the tolerance. So if I tell you that a company has a tolerance of 0.05 and they have an ideal of 6.3, they might ask, is it all right to have an item that is 6.4? Is that okay? Or is that outside of our range of our tolerance? Well, what we can do is we can substitute some of these in. So I can put 6.4 in for my actual. My ideal is 6.3, and I want that to be less than or equal to my tolerance, which is 0.05. Well, when I do the subtraction, I get the absolute value of 0.1. And when I look at that, that is not a true statement. 0.1 is less than or equal to 0.05. That is false. Well, since it turned out to be false, that means this box right here did not fall within my acceptable tolerance. So I would not be okay with having that particular item. Okay, here's our last set of practice problems. Go ahead and pause the video and solve each one of these and see what you come up with. Alright, on the first one I set up my two separate equations here, in the green and in the blue, solved each of those, and then I also went and I decided that this was going to be an AND because my inequality pointed at the absolute value. So I rewrote them as a compound AND statement. Second one, did a similar type of thing. I rewrote my two separate inequalities here, solved each of them, and I decided that it was going to be an OR statement. So I went back and I rewrote my answer as an OR statement.